All right, guys, so we are going to be doing an aluminum wire stoichiometric calculation lab. Okay, so we're going to be calculating the theoretical yield for copper. So we're going to be taking copper chloride, putting in an aluminum wire, putting it in a hot bath, heating it until we have all of the copper chloride transition into copper, and the aluminum will go into solution and form aluminum chloride based on the chemical equation. So we're going to pre-weigh our copper chloride, and then we're going to pre-weigh our aluminum wire. Okay, so I'm going to do that right now. So now I'm going to start with the aluminum wire, okay, or excuse me, the copper chloride. All right, and I want approximately 0.4. Okay. Oh, that's way too much. Hang on. Okay, so we're going to have 0.45 grams, 0.45 grams of the copper chloride. Okay, so now we're going to take the 0.45 and we are going to put it in a test tube like so. Okay, all right, and then we are going to add 10 mils of distilled water. So I'm going to pour in the distilled water. Okay, and then I'm going to pour it in here. Okay, and as you can see, it turns a really pretty blue color. I'm going to stir it up, okay, till the solid dissolves. And now I'm going to take it and put it in a hot water bath. Now, once I get that going, now I'm going to take an aluminum wire that I've taken steel wool and cleaned it with, okay? I'm going to mass out my aluminum wire. Oops, let me re-zero the balance. Okay, the aluminum wire is 0.53 grams. So I want you to write that down, 0.53 grams. Okay, and then we're going to stick the aluminum wire in the copper chloride solution. So this whole process is going to take about 10 minutes. So while you're doing that, you guys are going to do some math. Okay, so the very first thing you're going to need to do is you are going to need to balance the reaction for copper chloride, balance the chemical equation, okay, right here. Once you balance the equation, then you're going to, and there's the bottom part, it says predict the amount of aluminum needed by the mass of copper chloride used. So my helpers are going to follow me over here, okay, and here is the equation for measuring how much aluminum you need in the reaction. So you're going to record the amount of copper chloride that we just massed out. That's going to go here over 1. Then you're going to do 1 mole over the molar mass of copper chloride. So you're going to add 1 copper plus 2 chlorines together using the atomic mass to get the molar mass. Okay, that number goes here. Then you would have already balanced your equation, right? So remember, when you do the mole ratio, it's what I don't know over what I do know. So I don't know aluminum, so that's going to go on top. So whatever the coefficient is in front over the coefficient of copper chloride, okay? Then the last blank is going to be the mass of aluminum. Brooklyn. So once you do all of your calculations, you're going to come up with the number of grams of aluminum you need for the reaction. So whatever you come up for here is how much aluminum you need if you've used all of your copper chloride up. So if this number is smaller than what we measured of the 0.5 grams of of aluminum wire, if this number is smaller, that means the copper chloride is the limiting. If this number is larger than what we massed out, then this is the limiting reagent, okay? Once you figure that out, copper chloride or aluminum is going to be the limiting reagent. Then you're going to come over here in the bottom part. Guys, can you talk a little lower, please? Then the next part, you're going to have, you're going to answer these questions, and then you're going to be doing your theoretical yield of copper. So whatever you decide the limiting reagent is here, you're going to put that here, do the molar mass here, and now we're trying to find grams of copper. So you're going to look for grams of copper. So you're going to use your balanced equation, So don't overdo what I don't know over what I do know. So it's going to be one of those two, depending upon which is the limiting reagent, and then the molar mass of copper. All right, so in a minute, once the reaction takes place, we're going to start back with part 2, where we're going to show you what's happening in the reaction, okay? So we'll start back in part 2 here in a minute, okay?